In this tutorial, I introduced the statistics module. You can access it by clicking on the Sigma button up here. And the best time to do this is once you've finished creating the astrometric and relative photometric calibration. Let's do this. So you get 5 plots, one for the sky background, for the air mass, the image seeing, the relative photometric zero point, and the image quality, the PSF ellipticity. If you do not have astrometry, then the seeing estimate will be the mean full width half maximum of all the sources in the images. If you do have astrometry, this will be based on stars only, so it is a much more reliable estimate. Also, if you do not have astrometry, you will not see any data for the mean ellipticity and the relative photometric zero point. The plots are interactive. You can click and drag in the plots to move the data points around. You can also drag on the axis. And if your mouse has a scroll wheel, you can scroll in and out either inside the plot, or you can zoom the axis like this or like that. There's a number of selection options. In this case, we're plotting data from the Hawkeye instrument at the Very Large Telescope, which is an infrared camera which has 4 detectors. If you want to see data only of one detector, say detector number 1, you type the number here and you update the plots. And then you will only see the statistics for this single detector. You can also provide a range of detectors, for example, detectors 1 and 4. So this is a comma-separated list. Another way of filtering the data is through image coordinates. For example, if you have a wide field imager that has 16 detectors and your target of interest is only located in 1 or 2 of these detectors, but you do not know a priori in which ones, you can simply enter the sky coordinates of the source here in these 2 fields. You can also display images by clicking this button here. And then when you select a data point, for example, this exposure here, it will be displayed. Let me rearrange the windows a little bit so you can see better. And then you can quickly cycle through the images. A very nice feature of this dialog window is also that you can easily reject exposures that you do not like. For example, let's say we don't like the ones at higher air mass. You right-click a data point, and then you can use, for example, the left arrow to select all the previous data points, or you, with additional right clicks, you can select a few more data points. And then by hitting the delete button, these images disappear. They're deactivated. You can see this in the memory viewer here. Scroll down. So there are already 5 of those, 4 of those which are deactivated. Here there are a few more. On the hard drive, you will find them in the inactive directory. Let's have a look here. They're located in a subdirectory called bad statistics. That's one. Now here are all the exposures that were deactivated. If you want to undo this selection, you can simply click here on Restore Data, and the images will be restored. So now in the memory viewer, all these deactivated images are active again, and this directory is empty. Another way of doing this is you can set numeric thresholds. For example, say you do not like images that have a seeing worse than 0.6 arc seconds. So you enter maximum value of 0.6 arc seconds here, and click return or hit return. And say we do not like exposures that have a background higher than 21,000 electrons. So background 21,000. Again, you hit return. Then all the data points that are shown red are the ones that you can deactivate by hitting the delete button. If you want, you can invert the selection by clicking the button here. In this way, you have great flexibility in deactivating very specific images. You can clear the selection anytime by clicking on the Clear Selection button here. Each of these data points corresponds to the data from one single image, from one single detector. If you work with a wide field imager that has 10 or 20 different detectors, then you might be in a situation where you want to throw away all the data from all detectors. If one detector is bad, say you know that the one up here has very bad seeing and you do not like it, if you hit the delete button, then you will only delete the specific image from that detector. However, if you hit the A button, then all other detectors from that exposure will be deactivated. So let's do this. I'm clicking the A button on the keyboard, and then in the memory viewer you can see that detector number 1 is deactivated, detector number 2 has been deactivated, and down here detector number 3, detector number 4. You can also see this on your hard drive, the corresponding FITS files. Even though we selected only one data point, all the other detectors from that exposure are now deactivated. Lastly, you can export this data plot for your future reference. So there it is. Thank you for watching. I hope this was useful.